Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. Once again, we meet in the next slide. So hopefully that everyone is aware and well informed about the course instructions and the course structure for ACC 3014. Okay, let's move forward to introduction to statistic. Okay, basically there are two types of statistic. The first one is descriptive statistic, whereby you are simply describing what the data shows. And the next one is inferential statistic, whereby you are trying to reach conclusions that reach beyond the immediate data alone. For instance, we use inferential statistic to try to infer from the sample data that what a population might think, or we use inferential statistic to make judgment of the probability that an observed difference between groups is a dependable one, or one that might have happens by chance in the study. So we can generally mention that descriptive statistic is something that we can conclude, that we can learn from the descriptions, as an inferential statistic is the vice versa, something that beyond descriptions. Okay, at the end of this lecture, students should be able to, the first one, identify data analysis via descriptive and inferential statistic. The second one, to represent data descriptively using graphical technique. And the last one is to represent data descriptively by numerical calculation. So basically, in this lecture, we're gonna learn or maybe kind of recall the graphical technique and numerical calculations that mainly involved in this subject. Cool. Moving on to the descriptive statistic. So basically, it is a graphical technique whereby it is used to describe the basic features of a data in a particular study. In fact, it also provides simple summaries about the sample and the measures involved. Together with this simple graphics analysis, they form the basis of virtually every quantitative analysis of data. Okay, we can divide the data into two, which is the first one is quantitative and second one is qualitative. So quantitative is something that are made from instruments such as rulers, measuring balance, graduated cylinders, beakers, and thermometers, whereby these results are measurable in numbers. In the meantime, qualitative data is something that you have to use your senses to observe the results. Moving on to the qualitative versus quantitative. So basically, qualitative data is descriptive information as it describes something or some data. In the meantime, quantitative data is in the form of number, which is numerical information. So we can see, right? For example, here the data is, it was great fun. So it describes something which is great fun. It describes the situation. But in terms of quantitative, you have to quantify the data, whereby we can divide it into two, which is discrete and continuous. So let's move forward about the definition of discrete and continuous. So basically, quantitative data can be discrete or continuous, whereby discrete data can only take certain values like the whole numbers, and by principle, discrete data is counted. Okay, hold on. Okay, discrete data is counted. All right. So basically, something that is counted is discrete data. In the meantime, continuous data can take any value within a range, and the keyword is continuous data is measured. So something that is counted is discrete data, and something that is measured is continuous data. Okay, let's move forward. To census or sample. Okay, a census is when we collect data for every member of the population. Okay, for example, right? So it is meant the whole population. It's like the whole population. Meanwhile, a sample is when we collect data for only the selected members of the groups. Okay. However, a census is accurate, but unfortunately difficult to retrieve. A sample may not be accurate but good enough and more practical to do. Okay, let's move on to the graphical to the graphic to the figure representations. Okay, so this is basically the sample. Okay, this is the whole population: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Basically there are like 12 populations, and the difference between population or census and sample is what is included in the population. Okay, for example, right here we can see 2 comes from this population, 5 comes from this population, and 8 also come from this population, and 10 also come from this population. So basically only take the selected data to represent the whole thing, the whole population, which might which may not necessarily be accurate but good enough to represent the data. Okay, basically let me explain briefly the types of graphical data available. So the first one is the bar graph. So bar graph is commonly used. I bet that you have used you have constructed this kind of graph as I listed here. So probably you are more familiar with this kind of graph. So for example, right, the bar graph is the graphical display of data by using bars of different heights. So as I present this slide, so you can Google at the same time on the types of data, because after this I'm gonna give you the exercise on every single data. On every single graphical. In every single graphical data representation, so that you can learn the difference. Okay, so the second one is the histogram, which is the graphical display of the range of numbers by using bars of different heights. So the difference between bar graph and histogram is histogram involve the range of numbers, unlike the bar graph. Okay, in the meantime, there is also frequency histogram, which is a special histogram that uses vertical columns to show frequency, whereby how many times each score occurs. And next up is the line graph, a graph that shows information that is connected in some ways by using lines, which is such as change over time. Okay, next up is we have pie chart. I bet that you have been doing pie chart quite a lot. I mean, during the schools, and for your first year, or even in your um, general studies. Okay, so basically a pie chart is a special chart that uses pie slices to show relative sizes of data. And next one is stem and leaf plots, a special table where each data is split into stems. I think this is stem. Okay, stem, sorry, stem and leaf plot. There's no A here. The first digits or digits and leaf, usually the last digits. And next up is we have scatter plot, a XY plot that shows the relationship between two sets of data. But in this data, the plot is scattered, so there is no specific uh, designed or types. So it is basically scattered. That's why the name is scattered. Where we can learn more about the scatter plot that gonna involve the regressions and in the last chapter. And line plot. Line plot is beneficial in real-time surveying or data collection. Okay, before we move forward with the next task, so I hope that you can understand the different features and the types of chart and the graph listed here. So I'm going to give you several time before we proceed with the exercise. Alright, see you.